when an instructor says this is a bunch of really key concepts, log off of TikTok, put your phone away, and which I shall do myself, and be prepared to pay attention to this because it's a critical central part of how Revit works. And this has to do with what AutoCAD would call blocks, what Revit calls components, which are the things you bring into a building, whether it's furniture or equipment or plants or people or cars or whatever. And with AutoCAD, that's all sort of scattered all over the place. Some is in other drawings, some is in libraries somewhere, some's online, some stuff you made. Revit understands that for a professional architectural designs tool, we really need to have that not only organized on disk so you can find everything you need, but organized conceptually so that all your furniture, when you decide I don't want to see furniture, you turn it off and it all goes off. Or you decide I want all my plants to be green, you can make all your plants to be green in a very consistent, organized fashion. We saw this diagram last time. What I want to be paying attention to mostly, really entirely today, are these two center sections about host elements, which are the walls and floors and ceilings that are built in place and that can hold light fixtures and mirrors and wall cabinets. And then the component families, the light fixtures and appliances and wall cabinets and stuff that we bring in on a truck. There are really two distinct kinds: the host elements that are built in place and the component elements that are brought in and installed. So just bearing in that distinction in mind. And we'll look at categories in a little bit, but I'm using the example of a door, a single door, where that comes from. First of all, there is its category just of doors. And Revit understands doors as things that take place in walls, not in ceilings, not in floors, got to be in walls, that open and shut, and that cut a hole in the wall. Other elements, by and large, don't cut the holes in things. And you just place a range, it's not cutting a hole in anything. You place a wall cabinet, it's not cutting a hole in the wall, just attached to it. So when we place things, we need to be understanding, first of all, where they can go, and second, of their place in the organized hierarchy of Revit components. The upper level is its category, door. The next is the family, and this is an important concept. This has to do with the physical structure of a door. So these three, because their geometry differs, they are different families within the category of door. And they can be very simple, they can be highly complex. The next step down from family is type, which in this case means identical underlying geometry, but different dimensions for the geometry. If this family is called door with rectangular window, rectangular glazing, these would all be members of that family, but they would have different sizes, maybe different heights, who knows what. But the basic geometry is the same. We're stretching stuff, but we're not adding a window. We're not making a window, a glazing be round or something. And last is the instance. And this is one particular door at some particular location. So even if we have two of these somewhere, one there, one there, those are separate instances. This hierarchy of category, family, type, and instance goes through everything we're dealing with in Revit. It's very consistent, as we'll see. Once you know how to modify the dimensions of one door, you know how to modify the dimensions of all doors. In fact, you know how to modify the dimensions of wall cabinets or title blocks or whatever it happens to be. A very consistent interface that we'll be seeing here shortly. So a category is an idea, a set of behaviors, but no actual geometry yet. Then the family has some actual geometry. The type has variations on that geometry, dimensional geometry, and the instance is what you actually place in your model. So with that in mind, so let's just go to new. And I'm really tired of it popping up with imperial multidiscipline. I never want to use that. I mean, unless I'm working on a hospital or something rather. And I'm getting tired of going over to browse and having to remember which one of these to use. What I want to do is to take this residential default template and bring it up to the top of that list. So it's just one that automatically opens whenever we're starting to do stuff. If you're doing a hospital or a medical office building, you might use the commercial one, but for all our experiments, we'll just be using the simple residential one. So I'm gonna cancel that for a minute. And I want to go to, I actually have to start Revit to get into where I need to do this. And while we're at it, some people have got this confused. When we're always working in projects. project model. I'm using those interchangeably. So we're using this template, which is an empty drawing with some settings. We're going to be creating a new project, not a new project template. Don't check this one. Just always check project. We can control to a very great degree our working environment in Revit, how it behaves. And I don't like the behavior where that multidiscipline imperial one pops up. So I want to change that. And that's over here under File, Options. And this is sort of, like preferences in Adobe or something rather. But if we go to File Locations, we see here the list of those files is that they show up when we start a new drawing. What we want to do is add the residential one to this list and bring it to the top. So that's just the one that's automatically there. So I go to add one of these guys, and we'll pick residential default, open. And then not only has it been added to the list, but if I use the up arrow, it'll now be on top, and that's just the one that'll we just go file new, and we'll be right into that one. So we'll say okay. So actually, let me close out of this one just to illustrate. So when we go to new now, it's right there, residential default, and you can just say okay. And as long as we're at it, we really don't need to see structure, steel, precast, and systems. Let's at least turn off structure. We might want some colors. Let's turn off steel, precast, and systems. And that's back in File, Options, User Interface. And we can see we got all the architecture stuff. We want that. We really don't need this stuff. We don't need any of these systems ones. They just energy analysis you might want to do at some point. Route analysis is useful. That way we can find our way out. It'll find the shortest distance from like the farthest space in a room to the exit, so we can leave that on. So I would turn off the structure and the systems one just to see what happens. So basically those tabs are removed. You can always turn them back on again if you need that. Sometimes this helps, if you're working on a smaller screen, things don't start to get shortened down. While we're here, we're not going to be dealing, we're only going to be dealing here in this project, this little test, with our first floor plan, our second floor plan, our roof plan, and let's say our ceiling plans. We don't need bottom of footing. That's a floor plan, which is we just don't need. We'll delete that. And I don't need either the basement. So I can, Revit uses a control click to keep like adding things to what you're picking. So I'm going to go to basement, control click, basement electrical. I don't need any electrical ones. Oops, basement. I was shift, control click, 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 control click. So with those selected, I'm keeping first floor, roof plan, second floor, and site plan. That should be enough. Right click, delete. Space is at a premium, especially on smaller screens. So if you got a list of views that goes down to here, but you only need these, you might as well get rid of the ones you don't need. We'll be adding in schedules and 3D views and stuff, but really these are the only plans we need for most of the stuff that interior designers can be working on. So just to use walls as an example, I want to go over like the general procedure for replacing a host element. And we did this, so we'll go through it quickly. We go to Architecture Wall. And anytime that you're on a tool and you see some letters in brackets, that's the shortcut for that. You can just type that instead of going all the way up to wall. So WA, and you don't have to hit enter. It's just WA. There's no command line here. And I'll just draw a wall. If I go to wall again, at the top of properties, and you should always have the properties palette turned on. It's just like having your windshield working when you're in a car. Properties will show you the current element, in this case, wall type, that's going to be drawn whenever we start drawing stuff. If you want to draw a different kind, just click here and pick a different kind of wall. And now when I go back to wall, the one that I picked has become the current element, and that'll be used until we switch it. So with anything you're doing, your walls or windows or components or roofs, there's always like a current one sort of waiting to be created. If that's not the one you want, you can go to the one that you do want, and then draw with that, place that. I mentioned before, any door can be switched out for any other type of door. So if I go ahead and pick the wall that I just made, decided no, I don't want it to be 8-inch masonry, I can select it. Again, just go to my drop down and say I want it to be something else, and it will become something else. We control all that here through properties, either pick something and change its properties, or to set a current type and then draw with that. This same process works for all the other hosted elements, walls, doors, roofs, ceilings, and floors, where we can place something and replace it with something else once we decide what that's going to be. We did floors before. Let's see how that's similar. We'll pick floor. And we're coming in with this generic 12-inch floor. With a wall, we're just placing 2 points. With a floor, we need to give it a boundary, which we can either draw with lines or rectangles or whatever you need. Once you have an enclosed perimeter, you hit finished edit mode. And there we have a generic 12-inch floor. And you might be asking, why draw with these generic ones? I spoke earlier about the idea of a line representing a decision. Let me take the walls, for instance. Let's go to medium. We'll deal with all these view controls next class. As soon as I draw a wall like this, I'm starting to imply that I know something about that wall. However wide it is, it's got these 2 thin layers on it. I might really not know what that is. And I don't want to start drawing things specifically until I know what they actually are inside. So you might end up, if you're measuring your apartment, you see, okay, my wall is now 6.5 inches here, the wall behind the kitchen sink or something or other. You don't really know what's inside there. So we draw it at 6.5 inches, whatever that happens to be, just generically. And then once you find out what that is, you can change it. Walls between apartments often have 2 layers of chipboard on both sides to get a fire rating, but you don't know that until you've cut a hole in the wall and taken a look, or you remove outlet cover and to see what things actually are. So don't commit to information that you don't know about. We can switch out floors just the same way. If we want to change this to something else, we can change it to a different kind of floor. Okay, so that was placing these host families, the things that the building itself is made of. Now, in terms of putting things inside it, we looked at this a little bit, but let's do it with some more attention to what's going on. Doors and windows are components. They come in on a truck and we go into the wall. But they're different from a range or a wall cabinet in that they cut a hole. So each of them has its own tool up here, doors and windows. It cuts a hole and puts it in there. Architecture window, which is different from everything else that doesn't cut a hole. And the way we place everything else is architecture, component, place a component. And the current component shows up here. Is it all pendant light hemisphere for you guys? Okay, first, why that? I don't know. Why not a chair? But if we don't have a ceiling yet to attach it to. So let's click here, and we can find within this list any families that are already included in this template. And so what we have here is, with base cabinet, double and 2 drawers, that's the name of the family. This geometric configuration. And then below that are its various types, which are the same thing, just different sizes. So they vary only, they're built the same, they look the same, they're just wider in this case. So let's just pick a base cabinet, and then we can place it in position. And that's showing that way so that when it goes underneath a countertop, we see the dashed lines to know that that's there. If we go into a 3D view, we can see that that's just how it is represented in plan typically. It's actually a true three-dimensional object. Any component that's in the casework category can be replaced by any other piece of casework. Let's say a vanity countertop with a round hole, because that's just a countertop, not a cabinet. But since they're all grouped together in the same category of casework, you can switch one out for the other. I really should have just done something like this. When you select something and then go over here, it will always be at the top in bold to show you what the current one is. But if we want to come down here and go to 48, then we can make it wider. That's the normal course. We have some basic thing and you're changing sizes, not necessarily families. So if we want to place a component that wasn't included in the residential template, so let's just say component, place a component, and I want to go to get a chair. Let's see what chairs are here on the search bar. I can type chair, and we've got, there's only one chair, this Breuer chair. Okay, well, I'll place that. But I want more chairs, different chairs. Where do they come from? Well, in AutoCAD, you go online and you go to any number of different places. In Revit, there's just one place you go. You go to architecture, component, place a component. That much is the same as loading one that's already in your project. And then we say, I need to load a new family. I need to load a different set of geometries that's not any size of this Breuer chair. So I go to load family. And I hope we all have this thing popping up for us, which is the US Imperial Library. And here under furniture, we have a couple of generic things, and then we also have neatly organized beds, seating, storage, and tables. Go to seating. And these are pretty generic furnitures. Really, they're meant to be placed until you go to a manufacturer's website and get the good one that you're actually going to be using. But let's just say chair executive. Okay. Then it loads that and I can place it. So a lot of what we're doing is picking from libraries of pre-assembled components. Let's go back and look at the kinds of things that we can load here that ship with Revit. I'll go back up to the top level. Annotations, this is north arrows and tags to identify objects in plan. We wouldn't say, okay, Herman Miller, whatever, right there on the plan over and over again. Just say chair number 1 and then have a key somewhere saying, okay, chair number 1 is always going to be the Herman Miller, whichever it happens to be. So that's annotation. Casework we use a lot. And that works into base cabinets, wall cabinets, countertops, shelving, tall cabinets, base cabinets. So we got, we get a little preview over here, and you can use this arrow key to scroll down just to see the different configurations of those. A lot of them. Countertops, some with holes, some without holes, some with fixtures already in them, some not. Shelving, closet shelf, pretty exciting. Cabinets and stuff. Columns, who cares? Conduit, who cares? Curtain panels, we'll get into these once we start putting together storefront walls like that. Doors, these are just sort of basic ones. And we go into, like, say, residential and find more elaborate ones. So it's highly organized, highly consistent. And as we start making our own, or modifying these to make them to be what we need, we might really be wanting to pay attention to how they're named. So when we see them in a list, ours look just like they're part of the list of the things there that come from Autodesk. Electrical, architectural, power, terminals, outlets, that kind of stuff. Oh, entourage is interesting. These use a technology called RPC for rich photorealistic content that company in Lexington invented, actually. They have somebody on a turntable, I think, and as the turntable revolves, it takes like 20 pictures of the person, basically from different angles, so that you can see that person photorealistically from a number of different angles. We'll deal with all this stuff more next semester. Furniture, did we look at that? Yeah, furniture, tables, that kind of stuff. Lighting, light fixtures. There's a distinction here between architectural fixtures, which tend to be an exterior, this should say out exterior and interior instead of external and internal, but we got lots of different lighting fixtures, some which attach to the ceiling, some which are on the floor, some which are on the wall. Some can go on any surface. Let's go lighting again, MEP. Some of these are the same, and then often they add in ones that aren't available for some reason in the architectural package, architectural side of things. Openings, plantings. Again, these are the rich photorealistic content. Planning, plumbing, fixtures. Equipment would be like water heaters. Here we spend a lot of time here, and bathtubs, different ones of those. So there's a lot here. Certainly you can rough out a project with what's here. I do want to call your attention to specialty equipment, which has a lot of stuff here, lumps them all together here in specialty equipment for classrooms, which is, books. I could use a lectern, lockers, that kind of stuff. Domestic, which is all the kitchen appliances. This is sort of generic. This is nicer looking stuff. And then high end is, walk-in, under-counter wine storage, whatever you want. And you can mix and match these completely. There's no distinction between them. It's just sort of conveniently keeping them in place together. So that specialty equipment has a lot of stuff that you probably won't find elsewhere. All this stuff. So as you start downloading, which you will, I mean, that's just part of the deal. Go to any large manufacturer's website, you'll be able to download their files in AutoCAD or Revit, or those are really the only two formats we're interested in here. Keeping track of them on your own computer, of the own stuff you brought down, something I'll probably address, let's just say next week. I'll share with you the folder structure that I use in my own office. In Documents, I have a My Revit Families folder with subfolders for annotation, furniture, and then under furniture is seating, that kind of stuff. It's sort of an empty framework there already. And then when I download a Herman Miller chair, I can just stick it in my furniture category and in furniture seating. So I can find it again and not have to search all over my hard drive or try to remember which project it was in, but I've really got it organized. And you don't want to save it back to the same folder as the families that come from Autodesk with Revit 2024, because when Revit 2025 comes out, it's going to have a new set of folders for furniture. You probably get rid of the 2024 ones and delete those folders, and you don't want your stuff disappearing. As Revit 24 leaves your computer, you don't want your families to go with them. So that's how you load one family at a time. But let's say that you were getting started doing a Taco Bell restaurant and you knew you needed like 6 different kinds of kitchen equipment, which you didn't want to have to go load one at a time. You just wanted to get them in the drawing so you could use them. You just wanted them to start appearing here in properties so you could use them when you wanted to. And for that, instead of placing a component, and place a component means get it and stick it here in this view, we can go to Insert, Load Family, and pick a number of, let's go to casework or specialty equipment. We have kitchen, food service, and I can use Control-Click to grab several of these and insert them all at once into my drawing, into the project. They're not yet here in the model, but then when I go to Architecture, Component, Place a Component, they're here, and I can go get that fryer and put it in place. So you can either load them singly, or you can bulk load them. And the last thing I'll show you is under Insert. Just under Insert, we have this thing called Load Autodesk Family. Let's say you have like no room on your hard drive for all those Revit families. They're all online right here. And initially they all show up together, so we can scroll down through all the families that there are there, and we can search like chair, enter, a bunch of extra chairs. Or we can go to any, let's kill that search. We can go get them just the same way that it's the same categories, the same way locally. And then I can just say load, let's pick the bar stool, load it. And now that's an interesting question. Has it been inserted into my drawing yet, or just downloaded? Let me check. Yes, it is loaded into this project, but it's not separately downloaded to my hard drive. Bear that in mind. Bar stool. And while we're at it, when I go to component, what I'm inserting in each of these is a specific type with a specific size. So you'll see with bar stool, there's only one. There's a family called bar stool, and then there's actually only one type of it. With the base cabinet, double doors, 2 drawers, that's the family. There are multiple sizes I can be doing. Okay, so looking at here, once I've zoomed out a little bit, I realize there are a bunch of levels here that I don't need. I don't need the basement level. Right-click, delete. My footing level, right-click, delete. My bottom of footing level, I can delete them. I don't need my I do want the first floor. I don't need the top of the foundation. So again, just in terms of sort of cleaning up any project for doing what you need to do and not having a lot of clutter involved is a useful approach. Let's get it back into the plan view by double clicking on first floor. Here I have the generic 6-inch wall, and I can change that to anyone. Let me just change it to generic 8-inch wall, so it'll match what I was doing before. You notice when I did that, because the wall was drawn with a center line, so it moves out in both directions. Now my base cabinet is no longer aligned properly with that. I need to drag that down and realign it. So let's say that I have measured my apartment, and let's say I need an 11-inch thick wall. So I go to my wall tool and click on here to see what's available to me, and I'll see that there just aren't any 11-inch walls, and moreover, I don't even know what's inside that wall. 11 inches is sort of a funny distance. So what I want to do is just take my generic 8-inch wall, turn it into an 11-inch wall, which we don't have here in this system. And so here's a process we're going to do over and over and over it again for the rest of the time that you're using Revit. We're going to pick something that's close to what we want to end up with, and we're going to do 2 things. We're going to say edit this type, edit the dimensions of this geometry, and we're going to duplicate it. Edit type, duplicate, edit type, duplicate, again and again and again. So we're going to take pretty much everything about it. We're going to change its name to 11-inch, and we're going to change its width to 11-inch. So I go to edit type, duplicate, and I'm just going to call it generic 11-inch. And there was a Revit adds the 2 in there just so that there will be, if nothing else happens, we will have 2 distinct names. We won't have 2 generic 8 inches, but I just want to go to 11-inch. And the name is merely descriptive. It doesn't control or affect what it's made of or how thick it is or anything. We're going to make the dimensions match, but right now this is all we know about it. It's 11. It's some kind of wall or something in there, and it's 11 inches wide. Okay. And then we go to edit structure, structure edit. So we now have this new wall type. We need to make its dimensions match its name, edit. And you can see it's got one layer of thick stuff, and we're just going to click on the 8 inches and change that to 11 inches. And say okay. And we'll deal with this at some point. So now we have a generic 11 inch, its name is 11 inch generic. It's 11 inches thick. This gets reported back from structure. We can say okay. So that got bigger. And if we click on it, we can see that it's now 11 inch generic wall. So the idea here basically is so many things are pre-made for us, either in terms of basic host families that the building's made out of, or the loadable components that come in on a truck. We can take what's there and modify them to make the dimensions be what we want without having to create stuff from scratch. Okay, and this same edit type duplicate applies to floors, walls, ceilings, roofs, all that kind of stuff. Now, same way, if we want to create a new door type, which is to say a new door size with the same basic geometry. Right now, this is a 72 by 84 closet door. So 6 feet wide and 7 feet high. That's awfully big for a closet. I would like to make this 5 feet wide and 80 inches tall. Again, I'll do almost exactly the same thing. I'll pick the one that's close to what I want, go to edit type, duplicate, give it the name I want, and I use the same format, like 60 inches by 80 inches, as opposed to typing out 5 foot by 6 foot 8, 60 by 80. Okay. Or already in use. Let's change that. Duplicate. Let's make it something weird. 63 by 80. It will be one of those. Okay. So we now have a 63 by 80 sliding closet door. And now I need to tell it actually how wide this is. I need to take the dimensions from its name and say, okay, width is 63 inches, got to put the inches in, and the height is 80 inches. And as we say okay, this one will then change to be the smaller size. Again and again and again, we'll be taking something that's there, edit type, duplicate, change the name, change the dimensions, and keep going with that. You know, whether it's a window or a door or a wall cabinet or a sofa, any of those that have dimensions associated with them, we can change those in exactly the same way. Okay, let's do this. Let's do the same thing with the floor. So I'm on the top of page 6. I want to just create a floor. I'll use a rectangle. I could use lines. I'll use lines. And that's coming in just as generic 12-inch floor, which we can see in 3D. If you just want to copy something, if you want to copy some a specific distance, you'd use the copy command. If you just want to get another copy of it somewhere, you can select it and then just hold down Control while you drag it with the mouse button and get an extra one. So this is my generic floor. We don't know what it's made out of, so it doesn't have any indication of what it's made out of. If we do decide, okay, this floor over here, I know I want to have a wood finish on it, I can select it. And just like anything else that we want to change, when something's selected and you click here in properties, you will just get a list of the things that it can be changed to in the same category. I won't be getting chairs and walls, and I'm just getting other floor types. And I'll change to wood joist with a wood finish, which we see there. Let me copy that one over to here, holding down Control and dragging it with the left mouse button. And I realize, oh, in this house, I've got 12-inch wood joists. I've placed a floor with 10-inch joists. Now I need to do, but they're really 12 inches, which is say actually 11 1/4. So how would I do that? Edit type, duplicate. Something's not right, edit type, duplicate will almost always make it right. So edit type, duplicate. And I want this to be a wood joist with nominal 12-inch joists. So I'll change the 10 to 12 and get rid of the 2 over here. Okay. And then what changes, just like with the wall getting thicker, the floor will get deeper. And since 2x12s are actually 11¼ inches deep, so we have the 2x12s, a layer of plywood, and then the oak flooring, finished flooring on top of that. Okay, we've changed the name. And as I click OK, this will change to the new actual depth. All these added up. And okay, we'll get out of here. Okay, and that got deeper. And it's now this guy. Okay, I'm going to finish up with some exercises we can be doing together. Let's start here at the top of page 7. Get into plan view and put down a piece of the 8-inch wall. Generic, just plain generic 8-inch wall. Escape. And then what I want to do is change this. It's in the right location, but it's the wrong type of wall entirely. I want eventually to change it to a 4 7/8 inch metal stud chipboard partition. So the first thing to do is to change it to something close to what I want to end up with. These are done alphabetically, so the exterior ones come before the interior ones. And we'll go to 4.5 inches. And if you turn on down here next to right next to the scale of this view is the button for detail level. Let's get this onto medium or fine so we can start seeing the layers in that wall. Coarse will just show us the outside perimeter. Medium will be good. So with the 4.5 inch wall, we have 2 layers of 1/2 inch chipboard and a 3.5 inch stud inside there. But for whatever reason, we need to change this from a wood stud wall to a metal stud wall that we'd use in commercial construction. Less flammable and goes up faster. But we don't have the metal stud wall. We've got it for a soffit, but we don't have it for our interior partitions. So we need to change this guy into one of the metal stud walls, which are 5/8 of an inch of chipboard on both sides, and then metal studs, which are 3 5/8. So what would be the first step? Edit type, okay, you're getting the picture here. And then what? Duplicate, okay. And here, this will still be an interior partition. And we'll just call it 4 7/8. 4 7/8 inch. And let's go ahead and call this metal stud partition just to make it very clear what we're dealing with here. And then we go to edit. So right now we haven't changed a thing except this name. Now we actually need to work on the structure of it. So we go to, just like we did with the others, we go to structure edit. It's always right here at the top. And we need to turn this wood stud one into a metal stud one. We'll start with the chipboard 5/8 on both sides, top and bottom, 5/8. And make the structure be 3 5/8. And then the last thing to do is to change the wood core, which has one weight and acoustical properties and insulating values, to the metal, which has a different one. So we click here, and we get these 3 little dot here, which will take us to Revit's materials browser, which is full of materials, and there are many more down here. But if we just type stud here in the search box, it'll bring up metal stud layer. So we're going to switch out, replace softwood lumber with metal stud. So I'll say okay. So now we have chipboard 5/8, metal stud 3 5/8, chipboard 5/8, adds up to 4 7/8. We can say okay, and check everything's right there, and we'll say okay. And it got just a little bit wider, another 3/8 of an inch wider. But now when we click on it, we see that it's a 4 7/8, which is standard for office construction and pretty much everything that's not residential. This little button up here turns thin and thick lines on and off. They will always plot essentially this way, but often it's hard to see how things go together when they're turned on. If we change the scale of, well, we'll deal with the scale later on, but I pretty much leave that off all the time. And it's always on when you plot, regardless of where it is here in where you're working. Changing the dimensions of a door is even easier than changing the depth of a floor. Place a door and use this sliding closet door. Oops, that's too big. Make the wall longer. Let's say we place that door for the closet and then realize, oh, we're not going to use it for a closed closet. It's got to be something else. And let's say I want that to be I remeasure the opening and it's an existing 33-inch opening or something. First thing I'll do is just change this door to something like close to what I want. Let's say 30 by 80. And I can move that just by selecting it and dragging it. And we can use its flipper arrows to do whatever we need in terms of location. And then if this wants to be a different size door, normally they come in 2-inch increments. But if historic home, this is 33 inches, and we need to make this door 33 inches wide, we can select it, and to make it 33 inches wide, easy, pick it, edit type, duplicate, make it 33, change the name, change the value, and you can ignore these rough width and rough heights. They get calculated if needed from the width and the height themselves. Apply, okay, and there that is 33 inches. If we just want to change the style of this from this door to a fancy one, we can select it and pick raised single. Do you have this raised single door with skylights? Okay, pick a different one. We get the whole. Actually, that's not a great example. For a closet door, I would say. Okay, well, none of these really float my boat. What I want is just a 6-panel door with no skylights. So to do this, I'll go bring that into the project. I'll load family, bring it into the project, and then I can replace this one with it. So that I can do it this way. I can either do I'll do component. Sorry, I'll do door, load family, go up to doors, residential, single 6-panel wood door. Okay. It used to be that when you do that, Revit would import all of these sizes into the drawing, which is just a lot of overkill. So many of these will come with this additional dialog where you tell it the size that you want. Let's say 30 by 80. Funny. Oh, I see they got all the 80s first and the 84s. 30 by 80. Okay. I can place that there just for fun. And then two ways to turn this door into this one. One would be to select it and over here pick the one that you want it to be, 30 by 80. I'll do Control Z. Another is, in AutoCAD we had the match properties command, which takes any source object and pastes all its properties onto the second one. And we have that here as well. And that's just, you can use modify right here, match properties, or you can just type MA, which is a lot faster than searching through all that. Click that, and you pick one thing, and then pick another, and it changes to it. It's exactly the same process exactly the same effect as doing it in properties. So I can use MA to turn this chair into this one, MA, source object, destination object. What we're going to end up doing today, import an AutoCAD plan, and then turn it into a Revit model with doors, windows, walls, kitchen stuff like that, just to get a feel for how this all starts to work together in a real project instead of just like random pieces of walls and floors. Let's look at windows for a minute. The shortcut, as you can see here, is WN for window. And the default one is just a 36 by 48 fixed window. And we can put it in here. If I was in plan, it would come in at 3 feet off the floor. If we're working in the elevation or perspective view, we can put it anywhere we want it. Not many residential properties come with fixed windows like that. So let's see if there's something more attractive in our list. Select it. And again, all we'll get is windows, fixed with trim, window, casement, double window, double hung. Let's do that one. Okay, looks nicer. So this is actually the outside of that window, which you can tell when you go into the first floor plan. If you select it, with the walls and the windows, they both have an outside face, which is indicated by the location of their flipper arrows. And really, you want them to be the same direction for like the waterproofing issue. So I think on this one, since the wall, this is the outside face of the wall, I'll pick the window and then hit the flipper arrows to make its outside correspond with the walls outside. So if this is the inside of the wall where the furniture and the casework is, the window is pushed out to the outside, flush there, and that goes up and down. And we can just easily change that to a casement. That's the kind that cranks out. So I hope I've conveyed that this is a systematic way that lets you work effectively. You don't have to be an artist or a CAD jockey to make this all work. It's sort of there to be used in a organized and consistent fashion. And what I like to do when we come back is import the CAD file that's in week 9 course content, and then see what's involved in turning that into a Revit model. There are a couple of different ways to bring an AutoCAD drawing into Revit. Let's just try, I have it here on my desktop. Let me just try dragging it in. There you go. So that's one way. We could go to Insert, Import CAD right here. There are two of these, Link CAD and Import CAD. Import will bring the drawing as is right into your Revit model and leave it there. Link CAD would maintain a link between what's in the model and what's on your computer. So if this AutoCAD file changed, then this would change over here. I pretty much always go with the import, unless it's a big project with lots of people working on it. But let's just try that one time. Let's just do Insert, Import CAD. I'll go get this on my desktop. And when you do it that way, you notice that when I just dragged it in, I can move this around. When you use the insert this comes pinned in place, and we haven't really addressed pinning things yet. But if it's not where you want it to be, you can see there's this sort of push pin thing. We can click on that, which will release it, and then you can move it around. And these will all be there in your first floor plan. They're not going to like go off in space somewhere. Anyway, I'm going to delete that. So maybe I'll just get rid of all of this stuff and move this sort of into the middle of my elevations. And the reason to be working here within the elevation views instead of out here is, right now this view is set up to look at stuff that's just this wide, looking this way. And if this is outside that line, it won't show up. So we'll just move it back into here. And if we look at that in 3D, we see it's just a flat floor plan. What we don't know about any of these walls is what they're made out of. So I'm not going to assume anything about them. I'll just be using generic walls, make them the right thickness. So when we finally find out what that is, we can update them. Yeah, we're just going to trace this with Revit. I do see on LinkedIn advertisements for programs where you just import your 2D AutoCAD file and it's a Revit file for which you pay money. Fancy. And I don't know how well they work, or I don't know how they work, and I don't know how well they work. In part because, all that the AutoCAD drawing has going for it is layers, and there could be 50 different ways to name the wall layer. I'm sure there are. How does it know what's going on? Anyway, unless there's an AI that, probably does. I just don't know. Anyway, so let's look first, before we start thinking about actually modeling anything, let's do a little research to determine what kinds of walls we're going to need. Let's just take this wall down here. Controls, sorry. And I think what I'll do, so I don't mess this up, I think I will, now that it's in place, I will pin it, which means it's in place and I can't accidentally move it out of the way or mess with it. It's going to stay there steady underneath our drawing. And then to find out how far apart these are, I want to introduce you to another tool. It's like Dimension, but it's the Measure tool. And we can just click it there, and we could click here and then click here, and it tells you 5 inches. So I got a 5-inch wall to make. I noticed that this, which I guess is going to be like the bathroom plumbing wall, is a little thicker than that. So let's use Measure again. 7 inches. And that's typical because you've got large pipes and stuff in there that just need a larger wall. And then lastly, the outside wall will be Measure an even foot. So I think what I want, assuming that there are no others, is a 5-inch generic wall, a 7-inch generic wall, and a 12-inch generic wall. Let's see what we got. We'll just draw those perimeter walls just to start with. And I don't have a generic 12-inch wall. I got some foundation walls, but it's not a retaining wall down there. It's not none of those. So we'll maybe just here, 11 inches is close. Start with that, and then we'll change it into, we'll create a new type of a generic 12-inch wall. So as we're placing these, they're going to come in like 20 feet tall just when we start. And right from the outset, I would like to have control over that. To say we're drawing here on the first floor level, I want it to go up to the second floor level, which is like 9.5 or 10 feet up. So the first thing I'm going to do here in place wall is say, instead of being unconnected, I want to say connected up to the second floor. At which point the 20-foot grays out, meaning that it's no longer effective. And in terms of placing these walls, what I really know, probably what I measured, I mean, this is a made-up apartment, but let's just assume that we measured it. What we actually, measured were these inside dimensions. So I'm going to, as I'm indicating my 2 points for each wall, I want that to be on the finished face interior. We don't know anything about the inside of the wall, what it's made out of. We just know where we hit the paint. So finished face interior. And then I think I can just draw my whole outside wall right from there. I'm just going to start here, and drawing clockwise around the inside of the building will keep the wall on the outside side of the line. So I'm just going to go around my perimeter here. And I'm not leaving room for windows or doors or anything. They'll get placed eventually. So typically, as interior designers, we don't care how thick the exterior walls are, but let's just get it right so there's no questions. Let's get into the 3D view just to make sure we're generally on track. If they came in like this, which would happen if we didn't tell them to be attached to the second floor, they come in at 20 feet high just by default. It's easy enough to with Revit to make these global changes to something so that they can, instead of having to do pick and change and pick and change and pick and change, you can affect a bunch of things at one time. And one thing Revit can do to select multiple things that are the same type and connected end to end is to hover over one of them, hit tab, and then click, and that will select them all. So hover till it shows up, hit the tab key, just a tap on tab, and then click. And then those, now that I've got them all selected, I can say not that they're unconnected 20 feet high, but that they're connected up to the second floor level. And they'll drop back down again. And that doesn't mean just that they're 9 feet high. It means they're attached to this level. So if we change the second floor level to, let's say 12 feet, they all go up to 12 feet. I'll leave them down at 9, Control Z. So let's get into the plan view. And we see that these, whether you drew them with the 8-inch generic walls, the 11-inch, whichever, they're too narrow. We need to make them 12. So how do we do that? We pick one and then edit, type, duplicate, edit, type, duplicate. Change it from whatever it is to 12 inches. And then actually go in and edit the structure to be 12 inches. So that'll fix that one, because that's the one that we picked. I guess I could have picked them all, but just to make it clear, if I get into the 3D view, and then now that we've changed one of them, we can select any of these. Hover, tab, select, hover, tab, click, and then it says multiple wall types selected. I understand that, but then we'll just say make them all be generic 12 inches, and they all pop out just that much more. It's really a great system. I mean, to do that in AutoCAD would just be so painful. It's just all these stretchings and back and forth. There is an add-in to AutoCAD called AutoCAD Architecture. Don't go there. It automates the drawing process, but it's nothing like as intuitive and slick as this is. Let's get back into plan view and do some 5-inch walls. And the question for these is, do I want to go down the center line of these walls? And I would say no, because we don't know where the center line really is for most of them. I would use, it doesn't matter which is the inside and which is the outside, but let's create that wall type and then see what we can do with it. Sound good. Let's use the wall tool. And I think, again, I'll use maybe a slightly narrower wall to start with, this generic 4-inch wall, so I can see I can see the other one sticking up past it. And inside, outside, it's the same stuff really. So if I start drawing here, I can see that wall coming along. I'm going to jump right over that gap. Uh, if it was drawing on the other side, I can hit the space bar while I'm drawing just to flip that wall around the 2 points that I'm working on. I think I'll just go clean over to here. And I think right now I'm in a hidden line mode. I'm going to go to a wireframe mode just to be able to see the AutoCAD drawing underneath. And just as this wall was too skinny, the 8-inch or whatever we use here needed to get fatter to become 12. So this one needs to get fatter to become 5 inches. I pretty much leave it set on interior just as a way of working. Once I have this guy, how do I change a 4 foot into a 5 foot, a 4-inch into a 5-inch? Edit type, duplicate. Boy, I guess you're getting sort of the idea of how this all works. Change the name. Now we got to change the structure. 5 inches. Okay. Okay. Bingo. We'll go over it in much more detail on Monday about the different viewing options and visible styles in Revit. But a helpful one right now, just to keep track of where you've put walls and where you haven't, is to, on this icon right here, right next to a detail level, is visual styles. And if we change that to shaded, then we can see where we've actually created our walls compared to the ones that are underlying it. And we're probably going to turn that off when we start placing the doors and things so we can see the jam lines. Now, a couple things. I've got this wall here and I've got another one down here that's just the same. I can draw a new wall or I can copy the first one down. But what's a little different here is that this is an opening where there's a header over the door. This implies that there's nothing there. It's just the walls go right up to the ceiling. So this is one of the few cases where I would draw this wall, one wall from here to here, and another one from here to here. They don't touch. They're not the same thing. They're not connected by a header above the opening. So I'll go back to my shaded view. I'll go to WA for wall. Oh, I need to set my new wall style to be current. So I'll do WA. And it was on generic 4 inches, and I'll set it, the current one, to be generic 5 inches. So now I should just be able to draw. And starting here, the direction I'm drawing it, the wall gets thrown down below it. I'll just hit the space bar and it'll go back on top. It's really important. Note that I'm ignoring doors for now. We'll put them in later. The last little thing while we're on walls would be, remember this one needs to be 7 inches. So I'll place this one wall, edit type, duplicate, and make a 7-inch one. Magic. Let's place some doors to see where they go. I think I'll turn this back to wireframe again. And let's start with some easy ones. First of all, I need to know how big these are. Let's start with the front door. I'll use a measure. Okay, 3 feet. And let's say that that one's a 7-foot high door, and it's got glass in it, sort of front door of the unit. Let's go to door, single 6-panel wood. None of these are really doing it for me. I don't want to do one with side lights, not a sliding closet door, so I'll go to load family, doors. We got some nested folders that keep the large categories together and then smaller and smaller within that. So residential. Okay. 30s. It doesn't matter. Anything that's not a plain flush door or sliding closet door. So again, let's say 3 by 7 feet. 3 feet, 36 by 84. And Revit doesn't know exactly where to put this, so I'm just going to put it here, and then I'll move it into place. Revit places doors and windows by their centers, and there's nothing here to click on right in the middle of that doorway, so I'll just place it and then move it. To move it, I'll click on it and use Move or MV and pick from here to there. So you can see here in the 3D view, this looks just like a rat maze that I built for my daughter in 6th grade. So you can see we've got an opening, a true opening here with nothing at the top. I want to talk about what goes on here in from the hall into the kitchen, which is a doorway. It's 80 inches high or whatever, but there's no door in it. It's just a door opening. If we go back to our first floor plan, go to door. This will be a new load family. We have this thing called door opening. It's just the opening. It's not there's no panel, there's no glass. Door opening. Okay. And then the one that we're presented with is this 36 by 84. We can just put, okay, we just put that in here. That's the biggest it comes with. But what we really want is one that goes from here all the way over to here, which is much, I don't know, 5 feet or something or other. So let's measure to find out what that is. I'll use a dimension this time. And when you're dimensioning, sometimes Revit can find what you're looking for and sometimes it can't. If you get near what you're looking for and hit Tab again, it will sort of cycle through the number of the available objects that are there. Once it gets to the one you want, you can click and then come over to here and it finds it. Well, that's a mighty strange dimension. I guess somebody measured this very carefully or drew it very, very sloppily. That's a possibility. But let's say we want our opening to be 5, 9, and 7/32. Let's say that's really important. Okay, let's just do it, just so they line right up. So I'm gonna take that opening, and how am I gonna make it wider? Edit type and duplicate. And we're going to call this, what was that? 5. Let's just call it 5'9". Let's make it 5'9". But 5'9" is 69 inches. Let's stay within the 69 inches by 80 inches. We'll ignore the 7/32. And then with doors, we're not dealing with a whole structural component here. We don't have an edit structure, which go right down and change the, oh, this is funny. Rough width, let's just change this to, see how this works, 5'9", and the height to be 80 inches. And these guys, I don't know what they're doing. Let's say okay. Maybe I have to set its rough width. Let's just go to edit type. Rough. Yeah, okay. Apparently apparently here, what I need to set here are the rough widths. That's a surprise. 5'9", rough height 80. Get rid of those. Make them the same. That's a little weird. Pi. Okay. Okay, it's actually taking its dimensions from that one called rough opening, which usually means to the 2x4s. I guess that's the closest we've got. Anyway, once it's there, then I can move it into place, select it, move it, click, and click. And we'll be a little 7/30 seconds off over there, but who cares? So you can see the difference between those two kinds of openings. Okay, we'll start wrapping this up. Doors, we know. Let's deal with windows because they have the additional thing of not only styles, but actually heights off the floor. Let's do these down here. Let's see how wide they are first. 2'10". And I said on here, these are casement windows, which swing open. So we'll have to decide on a swing, but let's get them in there first. Window. Scroll down to, I want a single casement. So I don't have a single casement here, window, 3 in a row. So let's go get one. It brings us back to doors, where we were last. Windows are all the way down at the bottom. Window, casement, single. Oh, there's a left and a right. Well, let's see which one is which. Oh, window, casement, triple. That's an interesting option for us. But I'm going to do one at a time for right now. Window, casement, single, left. And 4 foot high by, how wide was that? 2'10". Okay, well, we don't have anything that's like that. We're gonna have to take one of these that's somewhere close and make it what we want it to be. I forget, doesn't matter, because we're gonna fix it anyhow. And you see Revit places these in the middle. I'm just gonna get it the correct size first and then move it into place. Okay, they're all 2'10". So this is a little bigger. This is 3 feet. So we'll pick this guy, edit type, duplicate, 34 inches wide, 2'10". But 48 high is fine. And then we just scroll down to get to its dimensions. And for this, we don't use the rough width and rough height because we have wood trim all around. You can see it get a little smaller. Now I should just be able to move it over. MV to move to there. And then I can use copy to get those guys. I'm going to try putting in the triple casement unit. Let's pretend that that's 9'6", and see how that goes in instead of doing all these guys. A question from the floor about copying things. You can select something, hit copy or type CO, and then drag it from one place to the next. Note the little helpful video that plays when you select a tool and then don't use it right away. Okay, when I say I'm going to try that triple casement window just to see what it's doing. Window, nothing I have is even close, so I'll go to load family. I'm still in Windows. Window, casement triple. Triple awning. Oh, wow. These are all exciting stuff. I'll just do this one. And now I knew that that was 9'6" or something. That won't be a size we can get, which is, I'll just make it this one and we'll change it. And then I'll pick this edit type, duplicate. 9'6" is 108 and 6 is 114. You knew that. I guess you'll leave him. Okay, well, there we go. Save this. I'm calling it class 14 exercise.